All right, so your rational expressions is what we're going to focus on today. I had you do the A and the B, but we are going to go back in and fill in a few things together first. Okay, so we're going to simplify, multiply, and divide rational expressions, and then we are also going to add and subtract, and then simplify complex rational expressions. So the 3 steps for factoring, remember you want to find what they have in common or the GCF. You got to look for those special patterns that occur, and then we guess and we check with FOIL. Okay, so I had you guys factor this. You had the difference of 2 squares on the bottom, guess and check here. And then whenever you have a common factor, they divide out. Something divided by itself is 1. We can only do that because they're being multiplied. And then for this one, you guys probably did a nice job of canceling those out. And then don't forget, you also want to reduce. So 4 over 12, 4 goes into itself 1 time, goes into 12 3 times. So across the top, it's 1 times x plus 1. Okay, and then on the bottom, you are going to leave this in factored form. Okay, so I think some of you distributed because we were simplifying earlier. Okay, for ones like this, we are going to leave it in factored form, and that's what we're going to write here. And then remember, when you're multiplying fractions, you have to multiply straight across. The reason why I remind you of that is because sometimes people try to cross multiply and you go numerator by numerator, denominator by denominator. How do you divide them? You guys like to say keep, change, flip? Okay, and we will say that. Back in my day, it was skip, flip, and multiply. Okay, and so we're going to be writing all solutions in factored form. That means if there's a GCF, you have to make sure that you take it out. So factored form means you are going to take out the GCF. So we might have to check that with some of the ones you guys did on your own. And then just don't distribute the GCF, the common factor, okay, like up here. All right, so then when you are multiplying, you can divide anything out where you have the same number on the top and on the bottom. So when you guys factor this, we got x minus 2 times x plus 6 on the top. Negative 2 plus 6 is how you get the 4. On the bottom, this is x plus 4 times x plus 4. This is a special pattern. You can just write that out twice. And then did you guys remember to take out the GCF from 2x plus 8? Okay. And even if that's just on the bottom, I like to put it in the brackets because when you're multiplying across, all of those are being multiplied together. So if you can divide anything out, you can just cancel it. If you can just do a slash, so like when you're doing this on a test or a quiz, I'm just going to have to be able to read your work. So something that I can still read. And then on the top, you would have 2 times x plus 6. On the bottom, you would have x plus 4. So if you have 2x plus 12 on the top, all you have to do is factor out that GCF. All right, and then for B, you have x minus 5 on the top. This is the difference of 2 squares, x plus 4, x minus 4, and then we're going to do times, and so we're going to have to flip this. So what multiplies to 28 but adds to 11? 7 and 4, excellent. And they're both plus because it's a positive and a positive. And then multiplies to negative 15 but adds to negative 2. Good. All right, and then again, It doesn't matter if they're across from each other there because you're multiplying, they will divide out. I like to go across the top, so I look at this, then nope, yep, and then I know I found everything. So x plus 7 on the top. Because we're leaving this in factored form, you're going to leave it as x minus 4 times x plus 3, or if you put x plus 3 times x minus 4, that's fine too. But because it's in factored form, you do not have to FOIL that out. Okay? So it's actually less work than having to FOIL that out again. All right, and then for C and D, when you have the 3 minus x here, that can be a little bit trickier. So we're going to go over that one together. I know that some of you have already factored these. So that you'd have x and x. And then if it multiplies to a positive, you're going to have plus 3 minus 1. 3 minus 1 will be 2. And then here you'll have x minus 3, x plus 1. That multiplies to negative 3. Negative 3 plus 1 is negative 2. And then it wouldn't look like anything canceled out. Maybe you guys would see this one here, but you can also factor out a negative. So if you factor out a negative from the top here, the x becomes positive, the 3 becomes negative. Okay, this one you don't factor out a negative, you can just rewrite it as x plus 3, or you don't even have to if you don't want to. And then I'm just going to rewrite these so that I can cross them out properly. So now I can cancel out the x minus 3 and the x minus 3. Okay, you could cancel those out without having to write them, that's okay. And then if you're keeping it in factored form, you can keep the negative in front. This would be 1 because it is just a 1. If you wrote negative x plus 1, that would be okay as well. Okay, so you could write it like that, or you could write it as negative x plus 1. Okay, and I know I'm going kind of fast through those, and that's only because we did all the factoring together last week. So I feel like you guys are good at your factoring rules. Okay, so 4 is a perfect square, 9 is a perfect square, so we should have 2y plus 3, and we should have 2y minus 3. Okay, when you have a number in front, if it's a prime number, you just have 2y and y. And we want two values that add to negative 18. Okay, so it could be 1 and 18, 2 and 9, 3 and 6. So you guys can guess and check. You're trying to add to positive 9. And then will you guys also factor that one for me? Okay, so what do we get for this one here? 2y minus 3 and y. Nice. So 2 times 6 is 12. 12 minus 3 is positive 9. Great job. And then remember, these were flipping. So you have y squared, so y and y has to multiply to negative 6, add to 5. So a positive 6 and a negative 1 multiplies to a negative, adds to positive 5. And then you have 2y. And sometimes when you have anything other than 1 in front, people get a little confused. You just have to remember when you're guessing and checking that you're going to multiply the 2 by another value here. Okay, so if it's going to add to 3, you can have, if it's going to multiply to negative 3, you have to have a 3 and a 1. Is the 3 going to go with the 2 or with the y? The 2y. So this would be 3 minus 2, that's going to make 1. Okay, and then you can cancel. So again, I like to start here. So 2y plus 3, yes, I have that. 2y minus 3, yep, that's going to cancel. Y plus 6, that's going to cancel. And then y minus 1, that's going to cancel. So guess what your answer is? It is 1, because when you divide it, it's going to be 1. Okay, so when everything divides out, you are just left with 1. All right, nice work. Okay, now when you are adding or subtracting, you are going to have to have a what? A common denominator. Okay, so once you have your common denominator, then you are going to add straight across. And then the bottom is going to stay the same. Okay, so in your book, they just give you this property just to say, okay, once you have the LCD, you just add the numerators together. The denominator is going to stay the same. Okay, and then even though any denominator is going to work, if it's a common denominator, it's best to use the LCD because then you won't have to reduce. Okay, you want the least common denominator. Okay, so to find the LCD, you have to factor each denominator. And then you take the product. So product means you multiply. So take the product of the distinct factors. Take the product of the distinct factors. Okay, the distinct means that you are not going to repeat anything. Okay, so it has to be distinct, and then you have to use the highest power. A lot of times the highest power is 1. Okay, but you're going to use the highest power that appears in any factor. So that means if you had x squared instead of just x, you would have to multiply by another x. If you had like 2 binomials, the x plus 2 squared, okay, then that's the only time where you would have a repeat, if you have one in the bottom. Okay, so we're going to start with some simpler examples, okay? So we have 5 over x minus 1 plus x over x plus 3. Okay, so your LCD is always the factors multiplied. So this is a factor, x minus 1. This is a factor, x plus 3. So your LCD is just those two multiplied together. Okay, and then when you are doing that out, when you're doing this on your practice problems, you're not going to have to write this out twice, but you do have to show this step. So you have to show that you are multiplying by x minus 1 over x minus 1. This one you're going to multiply by x plus 3 over x plus 3. Why do you have to show that you're multiplying the top and the bottom? Bless you. Yeah, it has to equal 1. If you just put times the x plus 3, you are not multiplying by 1, and then that's changing it. Okay, so then once you do that, you can just write your denominator. Okay, but on the top, you are going to simplify, and that is when you distribute. So when you are adding or subtracting, you are going to be distributing. Okay, so I want you to, well, I'll do the first one with you, and you can do the second one. So 5 times x is 5x, 5 times 3 is 15, and then I want you to multiply those, and then we're going to combine the like terms. Okay, and then I want you to combine the like terms. And then if you do get something that you can factor, you are going to factor it. The bottom you're keeping factored, so don't FOIL it. Yeah. So keep it in factored form still. Okay, so if you combine your like terms, there's nothing to combine with x squared. 5x minus x is 4x plus 15. Because you have a positive and a positive, is there anything that you can that multiplies to 15 that adds to 4? No, because if you have two positives, right, have to be either 16 or it'd have to be 8, and that's not happening. So this is your final answer. Okay, so that's not factorable. And again, just like we said on the first page, we're always going to leave these in factored form. So you do not have to FOIL that out. That's just more work for you. We're going to leave these in factored form. That way, if there's anything to cancel out, we can cancel. Stay with me. Okay, and then, do you guys have any questions for me on this one?
No question.
All right, then let's try this one. And somebody may be able to do that without me, so if you want to go ahead and do that, you can. So think about what your LCD is going to be in this case. Okay, so you can think of this as like 1 over 1, right? That's your denominator. So if you multiply those together, it's just x plus 4. So when you're doing this, you have 2x minus 1 over x plus 4, and then it's going to be minus, when you multiply that, it's going to be x plus 4 over x plus 4. Okay, because we would multiply this to get there. Now, this is where you have to be careful, because when you have this minus, you have to make sure that you distribute the negative. This is what people miss. It's a small mistake, but it does affect your final answer. So when we make this into one big fraction over the common denominator, this would be 2x minus 1 minus x minus 4. Okay, keep in mind that this is a factor. Okay, keep in mind that you have to distribute to both. Okay, and then 2x minus x, negative 1 minus 4, negative 5, and then this would be your final answer. All right, and then the last thing we're going to do is a compound fraction. And again, all of this is things that you have done in previous years. In Algebra 2 Honors, in Algebra 2. Okay, and then if you do college algebra or have done college algebra, we'll do this again in there. Okay, so a compound fraction is a fraction in which the numerator, the denominator, or both are themselves fractional expressions. And again, can't say this enough that we are going to leave this in factored form. Okay, when we do a quiz, we're going to do a quiz like over 1.4 and everything we're going to leave in factored form. Okay, so when you are simplifying a complex fraction, some of you might remember the process from last year. So you have u over v plus 1 over v over u minus 1. You guys remember how we tackled something like that? Yeah, do the top, then the bottom, and then we do the division of fractions. Okay, so I always like to simplify the numerator. And then the denominator. Okay, so if you have the v on the bottom, the LCD on the top is going to be v. So we would multiply the 1 by v over v. So we'd have u plus v divided by v. Is that too fast or is that okay? So what we want is we want to have a one term in the numerator. So we're going to get the LCD for the numerator, which is just v. Yep, we're gonna when I say simplify in this case, what I mean is you want it to be one term. Okay, so you don't want any addition or subtraction in between the terms. And that means on the bottom, your LCD is going to be u. So we're going to multiply that by u over u. So it would just be v minus u divided by u. Okay, and then sometimes we forget when we see it in this form, this means division. So if you're dividing two fractions, that's where you're going to keep, change, and flip. So you're going to keep the numerator, right? This is the numerator. U plus v over v. You're going to change it to multiply, and then you are going to flip this one. So you keep the numerator. You're going to change this to multiplication. You're going to flip the denominator. Okay, now, in some cases, you might get something that cancels out. U plus v and v minus u, is that going to cancel out? No, even if I were to take out a negative, that would make this negative, so that doesn't make sense. So we would just multiply straight across. So if I did that, I'd have u times u plus v, and I'd have v times v minus u, and there's nothing to simplify there. So if I'm keeping this in factored form, I'm going to leave it just like this. Okay, so if you distributed it, you would just have to factor it again. Okay, so if we're keeping it in factored form, we want to keep it just like that. Mm-hmm. Oh, here?
Yeah.
You could only do that if you split it up like this, and if you divided them, it would go back to u over v plus 1. So you can't just cancel these out because of this plus u. That's actually a common thing that people try to do, is they try to cancel these out. But because you have the plus, you would have to rewrite it as u divided by v plus v over v. That's the only way you could simplify. Yep. Mm-hmm. And it will put you back there. Okay, and then B actually has a similar setup. We just have a binomial this time in the denominator. Okay, so let's focus on doing this part. Okay, so what's your LCD?
Why are you just calling me out? I'm sitting here minding my business.
You're going to hand drive or something. Okay, so get your LCD. All right, so what is your LCD for the numerator? Yeah. So if that's your LCD, you would multiply the 1 by C minus 1 over C minus 1. So if you want to just change that right away, the 1, if you multiply that by C minus 1 over itself, it'll be plus 1 over C minus 1. So let's just do the numerator. Okay, we'll work on that first. All right, so if I combine those, C minus 1 is my new denominator. So I have C minus 1 plus 1. What's that going to simplify to? Yep, just C. Okay, and then I still have my division. And then again, the LCD on the bottom just happens to be the same as on the top. Sometimes that happens, not all the time. So if you multiply, then you have C minus 1 over C minus 1 minus 1 over C minus 1. So I know the denominator has to stay the same. C minus 1 minus 1 is going to be what? Great. Okay, and then because this is division, we know that we can rewrite it as C over C minus 1 times C minus 1 over C minus 2. Okay, so you're changing that, and then you're flipping this. Okay, and then this time we do have a common factor. We have the C minus 1 that's going to cancel out. Okay, so you have C over C minus 2. Now this is another case where sometimes people want to cancel those out. You can't do that. This C minus 2 in the denominator of a fraction stays together. So when you have a division bar, this is actually in parentheses and this is in parentheses. They just don't write it. You don't have to write it. Right? So you can't divide C by C minus 2. Okay, that's not divisible. So this is going to be your final answer here. Nope, you could just leave it as C over C minus 2. I just want you to know that you can't just cancel out those C's and make it negative 1/2. All right, and then the last one we're going to do is x minus 3 over x minus 4 minus x plus 2 over x plus 1, all divided by x plus 3. Okay, so again, when you're looking at that all together, that's complicated. So let's just take the numerator. The numerator is what we just did on the previous page, so we can get the LCD and simplify. Okay, so we're just looking at the numerator. Our LCD is x minus 4 times x plus 1. Okay, and then I'm just going to write this over here just so that you can see better what's happening. All right, so what this means is you would be multiplying the second term by x minus 4 over x minus 4, and you'd be multiplying the first term by x plus 1 over x plus 1. All right, so we're going to simplify that. Now, when you multiply these, what process are you going to use? FOIL. Okay, so x times x squared. If you want to do these together, you can. So this would be 1x minus 3x, so negative 2x. And then 1 times negative 3, negative 3. This is another area where you want to be careful. You have the minus here. So I'm going to put the minus, and then I'm going to put what I get from the FOIL inside the parentheses so that I do not forget to distribute. Okay, you could also distribute ahead of time and make it negative x minus 2 and then FOIL. That would be another option. So x times x is x squared. Inside I have 2x, outside I have negative 4x, so this would be negative 2x. And then 2 times negative 4 is negative 8. Okay, and then all of that is over the LCD. So all of that is over x plus 1 times x minus 4. Okay, so this is all the numerator. All right, so again, do not forget to distribute. So you have x squared minus 2x minus 3 minus x squared plus 2x plus 8. Okay, and that's still over your LCD. Okay, and then now we can combine our like terms. So if we combine our like terms, you have negative x squared and a positive x squared. So those are going to cancel. Negative 2x and 2x, those are going to cancel. And then negative 3 and 8 makes 5. Okay, so that's going to simplify to 5 over x plus 1, x minus 4. Is that our final answer? Why not? Yeah, we still have the denominator, right? So this is the numerator. Okay, so what I have is 5x plus 1 over x minus 4 divided by x plus 3. This is the simplified numerator. I have to make sure that I divide by the denominator. So if I do that, I'm going to have to flip it. What is going to be the flip? Good. 1 over x plus 3. It's the reciprocal. Okay, so now we can just multiply straight across. 5 times 1 is 5. And then on the bottom, again, it doesn't matter what order you put them in, but this is going to be your final. Okay, and you can leave it just like that. So that would be factored form. So do not have to FOIL it out there.